In this video, we're going to summarize many of the methods for the preparation and the reaction of carboxylic acids and the different carboxylic acid derivatives. As we consider the preparation of carboxylic acids, we know that they can be produced by the oxidation of primary alcohols, and we can use something like potassium or sodium dichromate, sulfuric acid, and water. Or we can oxidize an aldehyde using essentially the same conditions, or we can oxidize the aromatic side chain. So if we have benzene or a substituted benzene where we have an alkyl group with at least one benzylic hydrogen, then this can be oxidized to give the benzoic acid. So if other substituents are on the benzene that aren't sensitive to the conditions, then they'll also be carried along for the ride. But whether we have one carbon or multiple carbons, we'll always end up with the carboxylic acid at the benzylic position. Again, as long as we have at least one benzylic hydrogen to begin with. And these conditions are essentially the same. We could use sodium or potassium dichromate. These are a little bit more forcing, so we often have to heat it up. And an alternative would be to use potassium permanganate. Carboxylic acids can also be prepared by oxidative cleavage of alkenes or alkynes. For an alkene, we would treat this with potassium permanganate, and that would lead to cleavage here. And as long as we're starting out with an alkene where the alkene carbon has at least one hydrogen, then this will be converted to a carboxylic acid, and this side would also be converted to a carboxylic acid. And again, that was potassium permanganate. For an alkyne, this can be converted by ozonolysis to carboxylic acids. So it will undergo cleavage here, and each alkyne carbon becomes a carboxylic acid carbon. Another way that we can prepare carboxylic acids is by the reaction of a Grignard reagent with carbon dioxide, followed by aqueous acid workup, and that will also lead to the preparation of a carboxylic acid. And finally, we know that carboxylic acids can be prepared by the hydrolysis of a variety of different carboxylic acid derivatives. So if we had an acid halide or an anhydride or an ester or an amide or a nitrile, all of these can be hydrolyzed to give a carboxylic acid. And we talked about the differences. In some cases, these can be carried out under acidic or under basic conditions. For example, with an ester, we have ester hydrolysis under acidic conditions or ester hydrolysis under basic conditions, which is called saponification. Next, as we consider the reactions of carboxylic acids, we know that these can be reduced using lithium aluminum hydride, followed by water, and that will give us a primary alcohol. We might want to be able to reduce a carboxylic acid to an aldehyde, but there's not really a good direct way to do that. We're not going to discuss any of those. So instead, we could either convert our acid to an ester and then reduce it with Dibol, or we could convert our carboxylic acid to an acid halide and then reduce it with lithium T-butoxy aluminum hydride, or we could reduce the carboxylic acid to the alcohol and then oxidize the alcohol back up to the aldehyde. So we're not going to talk about any ways to go directly from a carboxylic acid to an aldehyde. We also know that we can treat a carboxylic acid with thionyl chloride or with oxalyl chloride in order to convert this to an acid chloride, or we could use PBr3 to convert the carboxylic acid to the acid bromide. We have a few ways that we could convert a carboxylic acid to an ester. The most common way would be a Fischer esterification, where we use an alcohol and H+, or we could treat the carboxylic acid with base to convert the carboxylic acid into a carboxylate nucleophile, and then treat it with an alkyl halide to do an SN2 substitution. And then another transformation that we have seen would be the treatment of a carboxylic acid with two equivalents of an organolithium, and that will convert our carboxylic acid to a ketone. So the first equivalent acts as a base and pulls off this proton. The second equivalent acts as a nucleophile and adds to the carbonyl carbon. This leads to the formation of a hydrate, which then equilibrates to give a ketone. So we know how to prepare carboxylic acids from alcohols or aldehydes, from aromatic compounds with an alkyl side chain, from alkenes or alkynes, or from Grignard reagents, and we can prepare carboxylic acids from the different carboxylic acid derivatives. And we know how to convert carboxylic acids into alcohols, alkyl halides, esters, and ketones. For the preparation of an acid chloride, we know that we can convert a carboxylic acid to an acid chloride using either thionyl chloride or oxalyl chloride, or we could convert a carboxylic acid to an acid bromide using PBr3. Furthermore, we know that we cannot prepare acid halides by nucleophilic acyl substitution of other carboxylic acid derivatives. Instead, acid halides can be converted to all of the other carboxylic acid derivatives. So whether we're starting with an acid chloride or an acid bromide, we could react this with a carboxylic acid in order to form an anhydride. We could react this with an alcohol to form an ester. We could react an acid chloride or an acid bromide with an amine to give an amide. Or we can hydrolyze an acid chloride or acid bromide to give a carboxylic acid. In addition to this interconversion of carboxylic acid derivatives, some other reactions that acid chlorides and acid bromides can undergo would include reduction. So if we use lithium aluminum hydride followed by water, that is going to give us a primary alcohol. If instead we use this reagent, lithium tri-T-butoxy aluminum hydride, followed by water, then we can reduce an acid halide to an aldehyde. And then a few other reactions. If we take an acid halide and we react it with benzene or a substituted benzene in the presence of aluminum trihalide, this will do a Friedel-Crafts acylation, leading to the formation of an aryl ketone. If we treat an acid halide with Grignard reagent, followed by aqueous acid workup, we will get two equivalents of the Grignard adding to the acid halide, resulting in the formation of an alcohol, similar to what we would see with an ester. And the same thing would be true whether we use a Grignard reagent or an organolithium species, we would end up with a tertiary alcohol. But if we used a different organometallic species, in particular a lithium dialkyl cuprate, this will result in the addition of only one equivalent, leading to the formation of a ketone. So, acid chlorides or acid bromides can be prepared from carboxylic acids, but they can be converted to anhydrides, esters, amides, acids. They can be reduced to primary alcohols or aldehydes. They can be converted to alcohols, or they can be converted to aryl ketones by Friedel-Crafts acylation, or any ketone by reaction with lithium dialkyl cuprates. For the preparation of anhydrides, we can start with an acid chloride or acid bromide, and we can react this with a carboxylic acid to give an anhydride by nucleophilic acyl substitution. Anhydrides can only be prepared in this way from acid halides, not from esters or amides. But anhydrides can be converted to esters or amides. So treatment with an alcohol would give an ester. Now, because we have two sides to the anhydride, it's possible that we can think about the alcohol adding to this carbonyl or to this carbonyl. And so if we're just trying to convert this to an ester, we would probably choose a starting anhydride where these R groups were the same. If we react an anhydride with an amine, then we can prepare an amide plus the other one. Or if we carry out hydrolysis, then we can make a carboxylic acid, right, plus the other one. And another possibility is that we can reduce an anhydride using lithium aluminum hydride followed by water. But this wouldn't really be a very useful reaction just because of the way that anhydrides would have been prepared. But just to be more complete, they can be reduced. So when it comes to anhydrides, we're going to focus on preparation from or reaction to other carboxylic acid derivatives.